Number 1 says match each quadratic expression given in factored form with an equivalent expression in standard form. One expression in standard form has no match. So if we take a look here, you can do this a couple different ways. You can multiply these all the way out using area method, or you can use some of the shortcuts that you maybe know from doing many of these. So for A and for D, we see that they have X's and Y's, right? And no other numbers. And so if we look, we can kind of narrow down where or the options for these, right? So if I'm just going to underline this in green and this in green. So the ones that I'm looking at here would be the ones with X's and Y's in them. So this is going to narrow down for A and B, or sorry, A and D. So then the others are kind of what we're looking at for B and C. And so when we look at B and C, we know it's a difference of squares because we see the same terms, but then one positive and one negative. So when we multiply 11 times 11, we know that 121 will be the first number. And so if we look at number 1 and number 5, that brings us to number 1 as our answer for that one. And then we know if we wanted to do it all the way out, we would end up with a negative 11x and a plus 11x. And then we'd get an x times a negative x. We'd have a negative x squared. These middle terms total 0. And that's where you just get the 121 minus x squared. And then for C, we know that that one's going to be number 5 since we've kind of narrowed down our options. Again, this would be an x times an x. So we'd get an x squared. Our middle term, if we did x times the 11, would be plus 11x. Then we would do the negative 11 times x. And then we do the negative 11 times 11, which is negative 121. We know that negative 11x and plus 11x totals 0. So that's where the x squared minus 121 comes from. So then you would maybe see that part A is a difference of squares as well. So if you recognize that, then we know we're just going to end up with this y squared. The middle terms are going to drop out, and then we're going to get this x times negative x, which would give us negative x squared. So we'd have y squared minus x squared, which we see down here at number 3. Then for part D, the middle terms are not going to cancel out because we've got 2 negatives here. And maybe I'll do area model on this one since I haven't really been doing that on these other ones, just to remind you how you can do this. So we can put the x minus y on one side and then the other term x minus y on the other. Then you would do x times x for this first box and get x squared. We'd have x times negative y. So we're going to get negative xy for that one. X times negative y, again, is negative xy. And then a negative y times a negative y. The negative times negative is positive. And then y times y is y squared. So if we take these terms out of here, we have x squared minus xy minus xy plus y squared. And you see that these two middle terms are like terms, both an x and a y. So we have a negative 1xy minus 1xy, which gives us negative 2xy's, and then plus that y squared. And so that tells us number 4 matches that one. Another way you could have narrowed that one down is negative y squared times negative y squared is definitely going to give you a plus y squared final term. And so then you could have seen that in number 4 as well without maybe doing the whole area model. Number 2, both x minus 3 times x plus 3 and 3 minus x times 3 plus x contain a sum and a difference and have only a 3 and an x. If each expression is rewritten in standard form, will the two expressions be the same? Explain or show your reasoning. So I'm just going to multiply these out. This first one I'll do area model on, and the second one I'll just distribute. So for this one, we'll have x minus 3 on one side and x plus 3 on the other. So I'm going to multiply this out. So then this first box would be x times x. Then we'd have 3 times x. In this bottom box, we would be multiplying the x and the negative 3, so negative 3x. And then the final box would be the negative 3 times the 3, which is negative 9. So when we take these pieces out, we have x squared, a plus 3x, a minus 3x, and a minus 9. 3x and negative 3x totals 0. So this is just x squared minus 9 for this first part. Okay, so our first one in standard form is x squared minus 9. Then in our second one, so if we were to do this one, and I'm just going to do this one using distribution. So I'm just going to distribute each term. So I'm going to go 3 times 3, which is 9. Then we need to distribute the 3 to the x. So 3 times x is a positive 3x. So now we've distributed the 3 to both terms. So now we need to distribute the negative x to both. So negative x times 3 is negative 3x. And negative x times x is negative x squared. Then we've got these middle terms here, which total 0x because they're like terms. So we get 9 minus x squared for this one. And those are not the same thing. So these are not equivalent. And you can see that because you have a positive x squared and a negative 9, and this one has a positive 9 and a negative x squared. So they have different terms. Number 3, show that the expressions 5 plus 1 times 5 minus 1 and 5 squared minus 1 squared are equivalent. Few different ways to do this. I think the easiest is just by doing order of operations for this first one. So you would do these parentheses, and 5 plus 1 is 6. 5 minus 1 is 4. And 6 times 4 is 24. And then similarly for this one, if we follow order of operations, it tells us to do the exponents first. So we would do 5 squared, which is 25. Minus 1 squared, which is 1, and 25 minus 1 is 24, and we see that those are equal, meaning they're equivalent. So for B, it says the expressions 30 minus 2 times 30 plus 2 and 30 squared minus 2 squared are equivalent, and they can help us find the product of two numbers. Which two numbers are they? So basically, what two numbers are these? So 30 minus 2 is 28, and 30 plus 2 is 32. So this will help us find the product of 28 times 32. So then in part C, it tells us 94 times 106, write it as a product of a sum and a difference. So you want to know what's the middle number between 94 and 106 so that you can add and subtract the same number. So right in the middle of 94 and 106 is 100, because 94 is minus 6 from 100 and 106 is plus 6 from 100. So that's going to be the numbers that we'll use is 100 minus 6, which is equivalent to 94, and 100 plus 6, which is equivalent to 106. So then if we write this like this, we have 100 squared minus 6 squared. So then 100 squared is 10,000. And then 6 squared is 36. So then 10,000 minus 36 is 9,964. So then this is equivalent to 94 times 106. Number 4, write each expression in factored form. If it's not possible, write not possible. So if we look at all of these, we see binomials with two terms. So we know that if they have the exact same number, okay, or sorry, if there's a minus, then we can write this as the two numbers, okay, the square root of the two numbers, one with a plus and one with a minus. So there has to be this minus here, okay? It's a difference of squares, not a sum of squares. So part B is not going to be possible. And also part E is not possible. Okay, it has to be that difference of squares. So this plus is a problem. So then we can go ahead and write these other ones, okay, by thinking about what number squared. So x times x is x squared. So these are going to be x's. And then what number times itself gives us 144? And that's 12. So 12 times 12 is 144. And then we'll make one of these a sum and one of these a difference. And then we'll continue doing that same thing throughout the next couple. So 25 is 5 times 5. And then x squared is x times x. And then one is a plus and one is a minus, so that our middle terms drop out and give us just this 25 minus x squared. And then this last one, b squared, would be b times b. A squared would be a times a. 1 plus and 1 minus. And it doesn't matter if you switch the plus or minus around. I certainly could have written b minus a times b plus a. What you need to make sure is that you have one of each. Okay, that one is a plus and one is a minus. Number 5, what are the solutions to the equation x minus a times x plus b equals 0? So maybe you know this right away, but you can use zero product property to separate these factors and set each one equal to 0. And then you could solve this way. So we would just add a to both sides to get x by itself, because negative a plus a is 0. So we're left with x, and then 0 plus a is a. So one solution is a. Here, to get x by itself, we need to subtract b from both sides, because b minus b is 0, which gives us just x on the left-hand side. And then 0 minus b is just negative b. So we want a and the opposite of b. So not a and b, not opposite a, opposite b. A and opposite b is option number C, or letter C. Create a diagram to show that x minus 3 times x minus 7 is equivalent to this. So a diagram, so I'm going to do the area model for this. So we want a 2 by 2 box because we've got a binomial times a binomial. So put x minus 3 on one side and x minus 7 on the other. And then we'll multiply these together for each box. So this one is x times x, which is x squared. The second one on top would be x times negative 7. So we generally would just write that as negative 7x. This bottom one would be x times negative 3. So we would write that as negative 3x. And then negative 3 times negative 7 for this final box, which is positive 21. Then when we take out these terms, we have x squared minus 7x on top, and then minus 3x and a positive 21 on bottom. We see these two terms here are like terms. So negative 7x and another negative 3x gives us negative 10x total. And then we see that this is the same as this, meaning that they're equivalent. Number 7, select all expressions that are equivalent to 8 minus x. So one thing I like to look at here is that we have a positive 8, right? And we have a negative x. So those things have to hold true. That 8 needs to be positive and x needs to be negative. as we solve this equation, okay? Because another way you could think of this is plus a negative x. So 8 plus a negative x. So in part A, our x is positive and our 8 is negative. So that's not what we want. In part B, our 8 is positive, our x is negative. This is good. It's exactly what I just wrote right here, right? And then in C, we have a negative x, which is good. Then we have minus a negative 8x. And remember, we can change subtraction to adding the opposite. So this will simplify to negative x plus 8, which is a negative x term and a positive 8. So that one is good. D, we have a negative 8, which is bad. E, we have a positive x, which is bad. F, we have a positive x, which is bad. And then G, we have a negative x, which is good. And then a plus 8, which is also good. So G is also equivalent. Number 8, Mai fills a tall cup with hot cocoa 12 centimeters in height. She waits 5 minutes for it to cool. Then she starts drinking in sips at an average rate of 2 centimeters of height for every 2 minutes until the cup is empty. The function C gives the height of hot cocoa in Mai's cup in centimeters as a function of time in minutes. Sketch a possible graph for C. Be sure to include and label a scale for each axis. So if we count this bottom axis, which is going to be our minutes, right? So this is going to be our time in minutes. We find out that there's 20 blanks here. So I'm just going to count by ones. So this is 5, 6, 7, 8, 9, 10. And I'm just going to label every 5. 11, 12, 13, 14, 15, and then 20. And then this vertical axis is going to be the height of the hot cocoa. So I'm just going to write height here, and then I'm going to turn it sideways to put it on my axis over here. And if we count this, it gets us to like 14 or 13. So I'm just going to count by ones again and label every 5. So that's 5. And this is 10. So now we want to use this information. So one of the things we see is that Mai fills the cup to 12 centimeters. So that's going to be our initial height. So that's going to be right here. Then she waits 5 minutes for it to cool. So her cup continues to be at a height of 12 for the first 5 minutes. Okay, so it's not going up or down any height in that first 5 minutes. So we can just draw a flat line here. Then she starts drinking at an average rate of change of 2 centimeters every 2 minutes. So this means after 2 minutes, okay, so at 7, she'll be down to 10 centimeters in height for her cup. And after another 2 minutes, she'll be down another 2, another 2 minutes down to every 2 minutes. So this is the average rate of change. Now, one thing you could say is Mai is just going to constantly sip on her hot cocoa for whatever that is, 12 minutes. She's just going to sit there and just constantly drink at the same rate the whole time. However, that's not really very likely. Most people, when they're drinking some type of liquid, take sips and stop, sip and stop, sip and stop. So you just kind of you can do kind of whatever you want here. So if you want to say, all right, she's going to go down to here, drink that 2 centimeters, then sit for a while before she takes another sip. Then maybe she's going to take a little sip, sit for a little bit, then take another sip. But what has to happen is at the end of your 2 minutes, she needs to be at these dots so that the average rate of change is staying the same. So then maybe she sat for a little bit, then took a sip to get down to the next height level. Okay, then maybe she slowly drank for a little, or for that whole 2 minutes. Maybe she just sat there and actually did sip. Then maybe drank faster and then sat, drank fast. And maybe at this last one, I'll just have her sit for a little bit and then she'll drink and end at 0. So again, this is just a sample graph. Yours can be different than that, okay? But I would keep in mind doing this and having her go from here straight to the end doesn't really make a lot of sense. Most people are not going to just sit and constantly sip on something for 12 minutes at the same rate of speed. They're going to vary the amount that they drink. They're going to drink, set it down for a little bit, and go back to it. So keep that in mind as you draw it. Then it says, what quantities do the domain and range represent in this situation? So our domain, or our horizontal value, was the time in minutes since my filled her cup. And then the range was the height in centimeters of the cocoa in her cup. So then it says describe the domain and range. So the domain, it took her 17 minutes to empty her cup or to finish drinking. So this is going to be all numbers from 0 to 17. And then the range is going to be all height values, or all numbers from 0 to 12, which was what she filled her cup at to start. So she went 12 all the way down to 0, but when we write it, we like to write the lowest number first. So we'll say the range is numbers from 0 to 12. Number 9, one bacteria population is modeled by this equation, where D is the number of days since it was first measured. A second population is modeled by this next equation, where D is the number of days since it was first measured. Which statement, so one thing, is true about these two populations? So A says the second population will always be larger than the first. So this has to do with the starting value. So it does start above the first, okay? So that's one key piece, is we know initially it's higher than it. Then we need to look at the decay rate. So in this case, this one is keeping 50% of its population, right? It's losing 50%, it's keeping 50%. Where this one is keeping 33% of its population. So that means that this one, okay, is, like I said, losing 50%, but this one is losing 67% of its population after each day. So that means that this one is decaying faster than the first one. So that means it's going to cross over it and dip below it at some point, because it's decreasing quicker than the first one. So this is false. B says that both populations are increasing, which is not false, because their growth factors are less than 1. C says the second bacteria population decreases more rapidly than the first, which is true. We just talked about that. The second one is decreasing faster than the first, because it's decreasing 67% versus the first one at 50%. So then that means D has to be false, but we can just make sure. So when initially measured, the first population is larger. Well, 250,000 is not larger. So D is definitely false